Well, ladies and gentlemen, I have made it back. So I will be out of school today, but I will be back to school on Monday, I believe. So this is hopefully the last time I have to do some notes, almost like Zoom style, like we used to do it. But today we're going to look at the systems of equations that we have. And so with the systems of equations, I want you to realize that it's just basically two lines, and the solution to this, to a solution to every system of equations, is where these lines touch. And in these three scenarios, you can see that we can always have a situation where there's exactly one plot spot where these cross paths, one answer. There is, when there are infinitely many solutions, is when this is actually two lines sitting right on top of each other, which means that they're always touching each other, which means every single point on that line is a correct answer. And then there's something where we don't have any answers. These two lines right here will never cross, they're parallel. Therefore, there's not one single point or any points at all in which these things are going to touch each other. And so what we do with these solution methods is we look at the three different ways to solve these. So we can use the substitution method and the elimination method. I guess two of them are kind of the same. So we'll just focus on the substitution and the elimination. When you use each of these, it really honestly just depends on what you're given for the problem. Whenever I see something that has one letter by itself already, I think this is a perfect situation for substitution. And what we do is we say, well, if my y value is equal to 2x minus 11, why can't I just plug that in and substitute it for this value right here? So if I'm going to rewrite this problem right here, but place that 2x minus 11 where the y is, it would look like this. That y would turn into 2x minus 11. The right side, I get 3x minus 16. And from here, this is a pretty standard problem to solve, but you'll notice you're down to one single letter again, and the y's have disappeared or we have substituted them away. So to solve this personally, I would subtract 2x. That means these two x's are going to disappear. Negative 11 equals x minus 16. Let's get rid of the 16 by adding it to both sides. And once those reduce to 0, we find out that our x value, I'll write it actually like this, x value is actually equal to 5. Now, what I personally do with these systems, and this can be something that we stop right here, x equals 5 is not the answer. Because remember, an answer is a coordinate point of where these things are going to cross paths. We have the x value of that coordinate point. Well, what we're going to do with this is we are now going to take that answer and we're going to plug it back into one of these two equations. My personal preference, pick the ones with positive numbers and smaller numbers. So in this case, I'm probably going to pick this equation right here. It has a smaller x value and a smaller negative number. So what I'm going to do is I'm going to take this x equals 5. I'm going to plug it in right there. What it looks like now is y equals 2. That x turns into a 5, and we continue with minus 11. Your y value is 10 minus 11, or in this case, my y value is negative 1. Now again, that is not the actual final answer. Your final answer is the coordinate point version of these two. So we write these as the x comma y. This 5, negative 1 is where those two lines are going to cross. Now if we graphed these, you would see that that is exactly where that happens. Now, problem number 2, very similar. You'll notice that we end up with a situation where one letter is isolated by itself on one side, which means we're going to take what it's equal to, and we are going to substitute that in wherever we see an x on the other side. All right, to do this, I have the 4. The x value turns into a y minus 10. Remember, whenever there are more than one things to plug in or there's multiplication happens, we need to make sure we utilize those parentheses. Continue on, there are no more x's in this equation, so now we are just left with solving this pretty normally. We're going to take that 4, distribute it in. We have 4y minus 40 plus 3y equals 16. I can combine together these 4 and 3y's to give me 7y's. And I can get rid of the 40 by adding those away. We end up with those disappearing. And the final, not quite a final answer, but 7y is equal to 56. Divide by 7. divide by 7. Once again, we get an answer that is not really the answer yet, but my y value should be 8. I personally, again, if something is important but not the answer, I like to put a box around it, kind of keeping my life a little organized for me. We are going to take that value, plug it into one of these two equations, whichever one we want. I pick the one with the smaller numbers or the positive numbers. Now, although this one has a negative in it, it does look like the x and the y's don't have anything really attached to them. That's why I'm choosing that one. So I have an answer of x equals my y value, which is 8, minus 10. This one was actually relatively nice. My x value is negative 2. Box it. Not the final answer, but close to it. Your final answer is written as a coordinate point, negative 2, comma 8. Substitution method works really well. Again, it's something that you should be looking for if there is one of those variables that's by itself, or you can get one isolated by itself rather easily. That method seems to work quite often. The other one that we're looking at is the elimination method. This is one where we try to line up our equations and we try to eliminate one of the x's, or either the x or the y's, by adding these two equations together. It seems really weird, but it's kind of like reducing them out to 0 like we do in a normal solving equations problem. Just a little fancier, realistically. Did this color show? Oh, that color does show up. Nice. All right. So here's what I'm talking about when we line things up. We need our x's to line up, we need our y's to line up, and we need our equal signs to line up. And if you look at this equation right now, those don't line up. The x's do, but the y's and the equal signs do not. So my suggestion is we try to move the y's over to the left-hand side, make it look a little bit more like this equation that we have up top right here. So if I'm going to rewrite this equation right here, what I'm going to do, and I oftentimes like do this off to the side. So I'll rewrite this equation, 6x minus equals negative 18y plus 10. The reason I do that is because if I do it right here or underneath that, it does get a little sloppy. I try to save all of this space for some of the actual elimination process. So if I add my 18y's to this side, 18y's to that side, we will see the y's disappear. But again, we have x's and y's on the left side, so they're just really going to stay on that side. We just moved them over. And if I take that equation and I rewrite it underneath this, 6x plus 18, should be a y, equals 10, I look at these equations now, and if you forget about this one for a second, not forget about it, but we just changed it, so it's not like we need it right now. But when you do this, you do now see that everything lines up. My x's line up, my y's line up, and then my equal signs line up. Once you are at this stage, it's a good place to be because we can start the elimination process. Now the goal, I want to add these equations downward like this, the x's, the y's, and the numbers. But when I do that, I would like either the x or the y to kind of reduce itself to 0. Unfortunately, neither of those would reduce to 0, so what we do is we manipulate one of the equations. The one that I'm going to manipulate is the top one. And I'm saying, I bet if I multiply this by negative 2, and what I mean by that is if I take that and I distribute that to every single portion of this equation, I can change the equation a little bit. Watch what happens. I chose negative 2 because when I do this first rainbow over the way to the beginning, I get negative 6x. Well, guys, guess what? When I add these together, those are going to reduce to 0. That's exactly what we want. We continue, though. The negative 2 times 8 is negative 16y's. The negative 2 times 40 is negative 80. We can now add these two equations together. If I take this equation and I add them, oftentimes what I'll do is I'll make sure that they're stacked on top of each other, so it makes it a little bit easier to see things, and then we just add them downwards. When I do this, these two, I'm actually going to switch to my normal color. These two are going to actually disappear now. So 18 minus 16 should be 2y's. We get negative 70 on the other side, and then this becomes a pretty standard algebra problem for us, in which we divide by 2, reduce, and we find out my y value is negative 35. Not the answer. My answer is when I actually plug that into something and I get a numerical value back. So in this situation, let's see what I got here. Well, I will need my handy dandy calculator probably for a little bit of these calculations. Let's see what we got. Because what I'm thinking is if I plug in my values, let me show you what I'm doing. We can choose any of these equations that we want. The funny thing is that they will all work. It's just a matter of which one do we want working easiest for us. And again, I choose the smallest numbers I can that also are positive. If I'm looking at that, I think that very top one looks like, unfortunately, the smallest one that we can work with. So I'm going to take it, I'm going to substitute in for the y value wherever I see that letter y. I'll plug it in right there. 3x plus 8 times negative 35 equals 40. I'm not going to lie, that is something I would need to plug in my calculator as well, which I'm going to do right now. Negative 35 times 8. I get negative 280. Holy smokes. I think that'll become a little bit nicer for us in a second. Add 280. Add 280. We're going to see those disappear. 3x equals 320. And I don't know if I made a mistake or not, but that is not going to be a nice number. I got what x equals, this would be 106 and technically 2/3 when I plug in my calculator. I'll have to come back to this one in a second, unless I made a really silly mistake. Oh my gosh, guys, I did. Oh my gosh. All right, I'm not going to go back and fix this one, but I will show you where I did mess up. Since you guys are not here to tell me this, negative 2 times 8. Oh, I did get negative 16. Okay, no, that was good. I saw negative 18. All right, well, I'm going to come back and double check this one just to verify on my keys, make sure I didn't mess this one up. But we're going to continue on with the other problem. Hopefully they'll be a little nicer than that one. Going through again, we're going to use the elimination method. When I always look in this information, they always do line up. I got x's, I got y's, I got numbers. But in this time, none of them again are going to add together to give me a 0. But what I do see is one of them is already a positive, one of them is already a negative for the y values. For me, that makes, I think, life a little bit easier. When I look at these, I say, well, the least common factor between these, or that we have, is we could use the 12. We could take that top one, multiply it by 3. That would give me 12y right there. We could take the bottom one, multiply it by 4. That would give me negative 12y. And I would be able to add those together to reduce them. So let's see what happens. When I take the 3 and we distribute, I do end up with 9x plus 12y equals, that is 84. And then if we do the same thing on the bottom, I'll take that 4, distribute it through. We end up with 8x minus 12y equals negative 16. And these I can add directly. I'm just going to move them up a little bit, give myself a little room. If I add these two equations together, the first thing that is going to actually eliminate from this are these two guys right here. Perfect. 9 plus 8 is 17x's. 84 minus 16 is 68. And again, I'm going to have to use my calculator for this one too, real quick. I hope it comes out to a nice number. It does. Once I divide by 17 and divide by 17, I am going to get x equals 4. Not your final answer. The main reason for that is we have to plug it back in. If I was going to choose one, I do see the smaller numbers, mostly a majority in this equation. So let's see what that looks like on the right-hand side here. 2, my x value becomes 4, minus 3y equals negative 4. Now you can use the original equation. There's no reason for us to really want to choose the larger number one, but whatever your heart desires, honestly, you can work with. 8 minus 3y is negative 4. I'm going to subtract 8 from both sides. Once I do that, goodbye. And finally, ladies and gentlemen, after doing a little bit of algebra, we find out that my y value was actually supposed to be 4 as well. Write those two as a coordinate point, and ladies and gentlemen, you've got yourself a final answer. So that's kind of the theme that we see here over and over and over is usually there's a decent amount of work for these solving equations. You'll notice that pretty much the same thing happens no matter what you do. You have a section, I try to keep it organized, where you do all the elimination itself to solve for one variable. Then usually there requires a little bit of work on either side to solve for the other portion of the coordinate itself. So I'm going to fly through these next two. I'm probably not going to show a ton of work for you, but you guys can always take a look at the keys to the homework if you guys need some help with these. I'm looking at this. Everything's lined up. I could multiply these x's together and get there. They're both opposites. The y's look really good as well. So it looks like the same number is going to actually be used for both of these. If I multiply this one by 2 and I distribute everywhere inside, I will rewrite that equation as 4x plus 6y equals positive 12. And if I add these downwards, this is the weird part, those are going to reduce to 0. These are going to reduce to 0. And my gosh, these also reduce to 0. The final equation, once you add all of these together, is weirdly 0 equals 0. Ladies and gentlemen, this is one of those special cases that we talked about up front, where we don't have one answer. We either have an infinite number of answers or 0 answers. The easiest way to tell, when you solved that equation, those x's and those y's disappeared. Did you end up with a true statement? Yes, 0 equals 0. This has infinitely many solutions. And guys, you know the best part? I'm solely fine if you guys write IMS, infinitely many solutions. Nice little shortcut for you. Last but not least, ladies and gentlemen, let's take a look at this one. I once again see positives and negatives here. We could have also done the y's. It does not matter which one we choose, but I'm going to take this top equation, multiply it by 2, and distribute. Those are too close together. Let's use purple and pink. Distribute, distribute, distribute. I'm going to write it underneath. I end up with negative 2x plus 6y equals 18. Check out this one. Another situation where the x's and the y's are going to reduce to 0. The other side does not. But when we write this, the left side has nothing on it, so 0 takes its place. And the right side I have 30. Guys, does 30 equal 0? Nope, it does not. So the answer to this is that there are 0 solutions, or in this case, the answer will be oftentimes, you can either write 0 solutions. That's usually the best way to go about that. I think that's one you guys would have to write out though. Awesome. You guys have the next worksheet to get through. I have made the keys available on Schoology. I'm sorry, I thought those were already published, but apparently they did not. They should be published now. And I will see you guys on Monday. Take care, friends.